To the seventh question, that is the conversion of molecules X to Y follows second order kinetics. If the concentration of X is increased to 3 times, how will it affect the formation of Y? So in this question, that is X to Y, first they have told that it is follows a second order kinetics. So we can write the general rate equation as R is equal to K into concentration of X raised to 2. So that order of the reaction will be 2. Again, they have found that if the concentration of X is increased to 3 times, then the concentration of X become 3x. So the rate it will be equal to 9x square K. That means 9 times the rate will be increased. That means for the formation of during the formation of a Y, the rate will be increased 9 times. Coming to the eighth question, that is identify the reaction order from each of the following rate constant. First rate constant K is equal to 2.3 into 10 raised to minus 5 liter mole inverse second inverse. Second rate constant K is equal to 3 into 10 raised to minus 4 second inverse. So in this question, based on the unit of the rate constant, we can find the order of the reactions. So here in the first question, the rate constant is given as 2.3 into 10 raised to minus 5 liter mole inverse second inverse. So we have to find the unit here, that is liter mole inverse second inverse. So for an nth order reaction, the unit of rate constant is mole raised to 1 minus n, liter raised to n minus 1, second raised to minus 1. So here 1 minus n is equal to, here mole raised to power is minus 1. So 1 minus n is equal to minus 1. So n is equal to 2. Again here liter raised to n minus 1. Here it is liter raised to 1. So n minus 1 is equal to 1. So n is equal to 2. Therefore, first rate constant is mainly of the order second order. So it follows a second order reactions. Again, so the second rate constant, that is K is equal to 3 into 10 raised to minus 4 second inverse. Here there is no mole power, there is no liter power. So that is, again for an nth order reaction, the unit of rate constant is K is equal to mole raised to 1 minus n, liter raised to n minus 1 second inverse. Here 1 minus n is equal to, here there is no mole power, that is equal to 0. So 1 minus n is equal to 0. So n is equal to 1. Again here n minus 1 is equal to, here also there is no liter power is there. So n minus 1 is equal to 0. So n is equal to 1. So this rate constant unit is mainly of the first order kinetics. So first one is mainly a second order reaction and second one is the first order reactions. So based on the unit of the rate constant, we can identify whether it is a second order or whether it is a first order or a zero order, etc. That is, show that in a first order reaction, the time required for completion of 99.9% is 10 times half-life of a reaction. So again, question is based on the first order kinetics. So first order kinetics, the rate equation, that is integrated rate equation, is found to be K is equal to 2.303 divided by T log A naught concentration divided by A. Again, in this question, it is 99.9% of the reaction is completed. That means the initial concentration we can consider, suppose it as 100. And then final concentration, that is left concentration, will be 100 minus 99.9. So it will be, so we can substitute in this equation, that is K is equal to 2.303 divided by T log of 100 divided by 100 minus 99.9. That is 100 minus 99.9 is equal to 0.1. So K is equal to 2.303 divided by T into log of 100 divided by 0.1. 100 divided by 0.1 is equal to 10 raised to 3. So K is equal to 2.303 divided by T log 10 raised to 3. Again, this is in the form of, that is log 10 raised to 3 means it is in the form of log A raised to B. Log A raised to B means B log A. So log 10 raised to 3 becomes 3 log 10. So we can substitute again, T is equal to 2.303 divided by K into log 10 raised to 3. Again T is equal to 2.303 divided by K into 3 log 10. So log 10 is equal to 1. So 2.303 into 3 into 1. So it will be altogether it is equal to 6.909 divided by K. So we have got the T. that is 99.9% completion. The time taken is found to be 6.909 divided by K. And we have obtained the T half of the reaction for a first order reaction is found to be T half is equal to 0.693 divided by K. So we have to prove that the time taken for the completion of 99.9% of the first order reaction is equal to the 10 times the half-life of the first order reactions. So we can divide this equation, that is T divided by T half is equal to 6.909 divided by K divided by 0.693 divided by K. So the rate constant get cancelled. So altogether we will get 6.909 divided by 0.693. 6.909 divided by 0.693 is approximately equal to 10. So hence it is proved that is T 99.9% completion is equal to the 10 times the half-life of the first order reactions. Coming to the last question, that is for a first order reaction, half-life is 14 seconds. What is the time required for the initial concentration to reduce to 1/8 of its initial value? So this question is also based on the first order reaction. Again, half-life is given, it is about 14 seconds. Again, half-life of a first order reaction is T half is equal to 0.693 divided by K. So based on that, we can find out the value of the specific reaction rate or rate constant. Therefore, K is equal to 0.693 divided by T half is found to be 40. So divide by 40. That is equal to 0.0495. So we have found the value of the specific reaction rate as 0.0495. Again, here they have asked that is initial concentration is reduced to 1/8 of the initial concentration. Then what is the value of the time? That is what is the time taken to complete the 1/8 of the initial concentration of the reactant. Then we have obtained the integrated rate equation as K is equal to 2.303 divided by T into log of concentration of A0 divided by A. Again, we have obtained the K value. Again, time we have to find out. So, T is equal to 2.303 divided by K value is equal to 0.0495 into log of initial concentration we can consider as A0. Again, final concentration means it is 1/8 of the initial concentration. So, it can be written as 1/8 into concentration of A0. So, it will be simplified as 2.303 divided by 0.0495 into log 8. So on substituting the value, we will get the time as 41.993, that is equal to 42 seconds. So this is the way we can find out the time taken to complete the 1/8 of the initial concentration of the reactant. So that is all in this session. Hope you like this session. Stay tuned for the next session. Till then, bye.